Hello and welcome back again to the programming bootcamp of the Code Maven website. My name is Gabor Szabo and with me is Nora. Hi Nora.
Hi.
I'm glad we are back, and after solving all these long exercises, let's get to the next chapter. Let me share the screen here. And just to remind you, this is the link, this is the website, and we are already into, like, I don't know, 19th episode of this series. And then this is the Python series, and here we have the next chapter, which is files. So we are going to talk about files and how to interact with files. So in general, there are two main types of files. One of them we call text files in general, and the other one we call binary files. So the text files are not only those that we have the extension txt, but also, for example, files that usually have the extension CSV, which is comma separated values. Wait a second, I'll have to move the picture here so I can see you. A Python file, a .py file, is also a text file. So beyond being a text file, one of them is also a CSV, and the other one is also a Python file, and the .pl is usually for Perl files, and then all kind of other extensions. Usually the extension reflects the format inside, and then usually there is this HTML files, which has usually the .html extension, XML, which is another format to store data. YAML and JSON, these are all textual formats to store some data in a well-formatted way. Okay, so free text is easy for a person to read, but if a computer needs to read in some data, then, for example, a CSV file is already, you are familiar with CSV, right? Are you familiar with CSV?
I know I've heard it, but I'm not sure what it's used
okay.
for.
So it's like an Excel. It looks like an Excel from your point of view. It's just a table basically where you have lines, and each line has fields, and the fields are separated with a comma. That's why it's comma separated values. Though actually there are similar files where the separator character is something else, semicolon or doesn't matter what, but there's a separator character. But here it comes actually the huge difference. So a CSV file that can store data in this way is a text file, but an Excel file is a binary file. So what is a binary? And from your point of view, they might look the same when you're editing an Excel, but the big difference is that any text file you can open with a plain text editor like Notepad or Notepad++. You can open it and see the content, and it might have all kind of signs that you have to get used to, meaning what are the meaning, but you can read them. Binary files, you need a special application in order to open them, read them, view them, listen to them. Okay, so all the other types of files like images and MP3 and MP4, these are all formats which are binary. So basically, that means that if we try to open with a text editor, we just see just all kind of characters have no meaning at all, no words in it, and no nothing. So even if you have an Excel file with your data in it, if you open it with a text editor, you just see a mess. Okay, and you need a special software in order to open it. Excel, for example, or there might be other applications that can open an Excel file, but you need a special something. Okay, so these are the files. Then there is another issue that I wanted to talk before we actually get into the code, is about the words open and read. So when regular people talk about opening a file, let's say you say, I open a file in Word. What you actually mean is that you looked for the file, you found the file on your file system, and then all the content is suddenly, you can see all the content in Word. Okay, that's what usually people mean by opening a file. Okay, same with Excel. When we say open an Excel file, we actually mean Okay, we go to the disk somewhere, and once we open the file, it's in the Excel, right? Same with Notepad++. You open a Python file, it's in Notepad++. Okay. Behind the scene, so the person who wrote the program actually has a different meaning for opening. For the programmer, the word open only means create some connection to the file on the disk. So later on, I can read in the content so I can display it, for example, to the user. Okay, so just the word open has a different meaning. So when we say in a programming language, doesn't matter if it's Python or C or whatever programming language, that we open the file, it doesn't involve any of the data that's in the file. It's only creating a connection to the file. So later on, I will be able to read the content of the file, and then if it's, let's say, Word, then to display it on the screen. Okay, so that's the big difference, and people have to remember that this is this difference. Okay, so let's go actually first for a couple of binary files, and I'll just give you an overview, because for the chapter in general is about reading text files, but I decided that it might be interesting to show you first a couple of how to read binary files. In order to read binary files, Python usually uses, or we usually use, some extra library, because internally a binary file, let's say an image, has its own formatting. Okay, that I don't know. I know that the CSV file looks like this: data, 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 comma, data, 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 comma, and so on. It's easy for me. It's a text file. But a binary file, it has the specification how it looks like internally, but I don't know, and I definitely don't want to learn it. So when I take an image, I want to open an image and maybe display it to a user or do something. I don't really care the internal format of the image. Okay, that's an abstraction over that. So we use a module. Some of these modules might be installed already. Some of them you might need to install. So I'm not sure that you will be able to run them. But let's just quickly see this. So there is a module called Pillow, actually, which is originally was called PIL or PIL. I think it's Python Imaging Library. That's the original name. And it's there so you can manipulate images. For example, I have small scripts that can take an image and resize the image, make it or crop an image given various parameters, and they all use this library behind the scene. But in this example, what I do is from the PIL module, I import the image object. Okay, this is after I installed below. So it's also a little bit strange. The name of the thing that we need to install is Pillow, but the actual module name is called PIL. And in capital letters. Anyway, I import the image library, and then I also have this sys just so I can run this program giving the name of the file at the end. So this is how I get the in file from sysargv. This is nothing to do with the image processing, just to get the name of the file. And then I can say image open in file. Now in this case, so maybe I even have to correct a little bit what I said earlier about open and read. So when at the low level, we are talking about opening a file. That's what I said is that connecting to a file only. When a library says here, for example, the image library says, we say image open, I don't actually know what happens. So probably if I read the documentation, I would understand, okay, whether it reads in the file or just connects to it. I think it probably reads in the file. So even though I said open for the programmer is only the connection, because this is already a wrapper around all the lower level tools, probably this image open actually means reading in the content in this object, in this image object. So now this IMG whatever name, you can give it any name, it's just a variable name, contains all the image and all the metadata that's in the image. So when you have, for example, an image file, it's not only what you see, it can also has all kind of metadata. Like, for example, what kind of camera you used, the GPS location, all kind of this metadata is also in the picture, in the file. And what I show here is that you can just access image.size, and it will give a print out a tuple, the two sizes, so the width and the height of the image. Or you can access the first and the second element of this tuple, which is the width and the height. And you can do all kind of other things, but the main point that if I want to deal with an image, I'm going to use, most likely, I'm going to use some library, the Pillow library. Okay. Going on, an Excel file, just for another an example. For this, I'm going to use the OpenPyXL module. Also something one need to install before using it. Here I'm opening it, I'm importing the whole module, and then I say OpenPyXL load workbook, and I give it the name of the file. So in this case, I didn't ask the user to provide the name of the file. Maybe I'm going to fix the example, so it's going to be more flexible. Instead of that, I have fixed here the name of the file, which is an Excel file. And it opens the workbook. Probably this, no, so you can see this one doesn't call it open. It calls it load workbook. It's totally up to the decision of the person or people who wrote this library, how they call these functions. And there's no rule for this. One only need to read the documentation to understand how it works. So this probably, I mean, based on the name, it probably loads the whole thing into memory and puts everything in this variable, which I called WB. And now on this WB, I can, for example, iterate over the worksheets. So in Excel, you remember you have these separate pages or sheets, and then you can iterate over them. So in each iteration, the WS is going to represent one of these sheets. And it has, for example, a title, okay, which is usually written on the bottom. And you can also access from in another way, you can say from the workbook, so this whole thing, take the worksheets, the first element of it, put it in a variable called WS. So it's just a separate way of using here. And then access from this worksheet, access element A1. So it's the box A1, and then inside it has, so each box in Excel has a value, a formatting, all kind of other parameters. So here I can access the value of it. And that's it. Now,
so what happens here if there is nothing in that particular cell?
I guess it will be the empty string, or it will actually be none, probably.
Mm-hmm.
It will probably be represented as a none. Okay. Right. So the main point here is that for binary files, you probably will need to look for some specialized module that already knows how to deal with this, because there's no point of understanding how an Excel looks internally. Someone already did the work. Okay, we only need to use it. Okay, that's it. Now, there might be cases, special cases, and I'm actually dealing with one of them right now, when you have some internal binary format in your project. Maybe your lab, or if it's a company, your company has some machine, and it creates some binary format that someone made up, some C programmer decided that this is the format they want to save the data. And it's some proprietary format that no one else is using. In that case, you will actually have to go, and therefore probably there is no library for it, in no open source library. And then you will have to go and understand the format of it, and it's a lot of mess. Okay, it's a lot of work. So hopefully every time you'll have to deal with standard formats, and then you'll already have some library for it. Okay. Actually, I should have given a couple of this bio example. So I think, oh, I don't remember the names. There are all kind of files that represent, that contain DNA sequences, for example, or just generally sequences. And they too have metadata, for example, the name of the whatever animal that it was taken, or a living creature that was taken from, and all kind of other metadata, and the sequence itself. And they might be actually some kind of a text format, so you would be able to even open it with a text editor, but it has fields, and it's well defined fields. So there might be a module that already knows exactly how to access these fields. So even for text files, many times you have your specialized module. Okay. Okay, so we had these examples, and I'm going to find some examples for other types of files as well. So I think it's better. Now let's go just for regular text files. Okay, so just a plain text file someone gave you. It might be a report that was printed out, or an email that you saved as a text file, or anything. Okay, it can be just a plain text file. So here is the name of the file. Okay, in this case, apparently this is the file that has numbers in it, and I would like to read the content. So what do I do? And I actually don't understand what happened here. Oh, I skipped over one of the slides. Sorry. So this is the first example that I wanted to show. The first, which is, I'm now showing this as the first example because I think it's easier to explain this, even though this is not really the recommended way to use. Okay, but that's why I need two steps here. So here is the name of the file in some variable. You got it from somewhere, doesn't matter. You have the name of the file in a variable, let's call file name. And then we call the function open and give it the name of the file. And we also give the mode of opening. So you can open the file for reading or writing or appending, basically. These are the three modes. But at this level, so we are a much lower level than the application, you have to tell it that I'm opening it for reading. What you get back is what we call a file handler. So this definitely didn't read anything from the disk yet. Okay, it is only connected to the disk, to the location of this file in the disk. And then you get back a file handler, and then there are various ways to go over the content of this file. One of them that Python provides is just a regular iterator. So you can iterate over the lines of a file. And I used the variable name line just because they are going to be lines, but you could use any number, any word there. So it's just a variable name. You could use row or XYZ or whatever you like, okay? And this will, on each iteration, it will read one line from the file. And that's the important point, because in binary files, there are no lines. There's no meaning of lines. In text files, there is meaning of lines. Okay, so there's no point of using this in a binary file. Okay, and once you are done with whatever you did with the file, you need to close the file. And so you need to call fh.close. Parentheses. This will disconnect from the file. And why is it important? You might remember, I don't know if it still exists, but when you remove a discon key from a Windows computer, Windows starts to shout at you that you removed it, and all kind of bad things can happen. And usually bad things don't happen, but actually bad things could happen, because the way Windows works and the way here Python works is that it keeps a buffer of the things. Now, when we are reading from files, that's not that important. But when we are writing, then what actually happens is that when you say, okay, write this line to the file, and Python, or in general, the operating system, it will say, okay, I've done. But it doesn't do it immediately. It waits, it creates a buffer and collects some more that you wanted to write. And when there is enough, then it writes to the disk. Okay, so if you just wrote and wrote, and then you remove the discon key, or the program ended and it didn't have time to actually write to the disk, then that data can be lost. Okay, so it's important, very important also in Python to close the files. And it's important also when you're reading from a file, because there is a finite number of file handlers that a computer can handle. So if you just open files, more and more files, then you might run out of these file handlers. Okay, and then your program and your whole system will crash basically then. So it's a better idea to close them. Okay, now with that said, that's actually the reason that we don't recommend using it this way. The next slide shows the recommended way of using open. Here I'm using the with statement, which is called a context handler. Okay, in Python, inside the with I say with open, and then instead of assigning the result of open to a variable, I say sfh. So this actually does the same. It opens the file and assigns the result of this open to this fh, just like previously, but you don't see the assignment. And then it indented to the right, you have the same code as we had earlier, iterating over, but I don't need to call close here. And the reason I don't need to call close is because the with statement is a context, and once we leave the context, once this context ends, Python automatically closes the file. So I don't need to deal with this. And it's an extremely important thing, and I think really I don't really see, well, rarely, but maybe this can be useful, but it's really, really rare. So I'm almost every place I use this construct. Okay, but I decided to show the first one because I think that this construct, this second one, is a slightly bit difficult to understand this, how this happens, this opening and goes into the FH. Okay, so at least that's what happened the last couple of times I tried to explain this. Just this, it got created a lot of confusion. Okay.
I suppose it also has to do with this expression with and as not really resembling anything in spoken language, not like the for loop or the while loop where you can actually say sentences that are similar, I suppose.
Yeah, maybe. Yeah, I don't know. Maybe there is a with this open file as being called as fh. I don't know. Yeah. Right. So anyway, this is the and there are other places where you would use the with statement, but this is definitely one of the common places. Okay. So right. Let me just go back. Just one more thing here. So this thing doesn't do much. It just opens the file. Okay. This just connects to the file, and then this one is when it actually reads from the file, line by line, and then I just print it out. Now, if you run this program, you will see that every line in the file is printed, and immediately after that there is an empty row, and then again the second line, and so on. So this added an extra empty row between every two. Why did it happen? It's because when we are reading here, so on the file, in the file actually, what you have is text, a sign that is new line, text, a sign that's a new line. That's what in the file. And when we read from the file, it reads the whole text and the new line and puts it in the variable called line. But when we print it out, print also adds an extra new line at the end. So now you have a new line at the end of line itself, because that's what comes from the file, and prints also adds another new line. And that's why you have these empty rows, which is just for this display. So how do we get rid of it? Well, usually in the line, you don't really care about the new line. It was there in the file to separate the lines, but it doesn't have any other meaning. So you would like to remove it, okay? And so you would have a DNA sequences and the new line, and you don't care about the new line, you just want the content, okay? So our strip is write strip. It removes whatever at the end if it matches this \n, which represents a new line in Python. So this would remove the new line from line. It itself doesn't change this variable because it's immutable, but we immediately assign it back to the same variable because we don't really need the original one. We don't care, so we just overwrite it. And this time, this line already, this version of the line already doesn't have the new line at the end. Okay, and if, yeah, and that's it. Okay, and then you print out the line, and in this time you already have each line on its own without extra spaces.
So with this R strip,
Yeah.
would you be able to get any character off, not just a new line?
Yes, yes, yes. You could, you
right.
basically,
And then,
right? Go ahead.
So in that case, if the last character was not the character that you're looking for, then it would just remove the first one from the right that it finds?
I don't think so. I think it will only remove the right characters on the rightmost, so the
end.
From the end, right?
Mm.
Yeah. Well, and if you are starting from the left,
yeah,
yes.
yes.
Right. Yeah. So from the right side. And the interesting thing that I didn't know, I just found out a couple of days ago, I think, is that if you give it a couple of characters, so it's a string, then it will look for each individual character. So let's say you say R strip ABC, it won't look for ABC at the end. It would look either for A or for B or for C at the end, which surprised me, but that's how it
yeah,
apparently
it's not
works.
quite logical.
Yeah. Okay, but I mean, I think I've never used R strip for anything other than new line, well, except a couple of days ago, and that's how I found it out. So it's not that something that usually you use for other things. Okay, so this is what actually we saw already a couple of times, I think, is just getting the file name from the command line. So here we just check if this argv is different from 2, and if it's different, then we complain about it and actually tell the user to put the file name at the end. And if it's exactly 2, then from sysargv1 we get the name of the file, and then we do whatever we want. Okay, so it's actually not that. I mean, we already saw this several times. Now, before we go on, actually, I have a question. Why do you think we actually need this open part? Why not just start reading from a file? Why do we need this extra operation?
As you said before, this is the way for the program to actually access it on the disk.
Well, it is how to connect to it, yeah. But why do we need a separate thing for it? What happens in this operation?
In the open operation.
Yeah, the open operation.
It finds the file and defines what you want to do with it, I suppose.
Right.
So as in write or read or.
Yeah. Right. So the thing is that with this operation, I can access files on a hard disk, on an SSD thingy, through a network, basically, anything. I as the Python programmer, don't really care what is the physical device that the disk is in. I don't want to deal with this. This is a huge mess in itself. So the operating system underneath, okay, Windows, Linux, whatever you have, knows how to deal with a CD-ROM, a hard disk, a floppy disk, or an SSD, a disk on key, and you don't care. You only give it the path to the file, and then the operating system knows how to deal with this. So that's one thing. But then there's another thing is that the operating system has this rights management. So in every operating system, for each file, you can define which user can read it, which user can write it, and so on. Now, probably that you're not that familiar with this because you usually work on a single user computer, so you have all the rights for everything. But it's much more important when it's a multi-user computer, like a Linux machine, which has more than one users, and then there is a super user, or in Linux terms, it's called root. And Windows, it's actually, there is also something which is called administrator, but usually in most installations I've seen, people are configuring themselves to be the administrator, which is a problem in itself, but that's another separate story. But then it means that you don't have this question. But there can be easily files that I create and you don't have the right to, let's say, change it. Or maybe you don't even have the right to read the content. Okay, or vice versa. So it can be the same way on the other direction. And if I write a script and you run the script, then your rights are relevant. So maybe with the same script, I can open a file, but you can't. Because when you're writing, your user doesn't have those rights. Okay, so the open, when I call open, actually it asks the file system, please check, verify that I have that the file exists. Okay, maybe I gave it the name of a file that doesn't exist, a path that doesn't exist. And if I have the rights to do whatever operation is mentioned here. Okay, so in this case, reading, sorry, reading. Okay, so right, so this is one of the reasons why it's useful to have a with statement. In this case, what we do is we open a file with this inside a with statement, and then for each line in the file, we do something. So the first thing we do is we get rid of the new line from the end, and then we say the next thing. So if the line, the current line, is longer than 0 characters, and the first character is a hash mark, then it's probably a comment, let's say, and then we return. We don't deal with that thing anymore. Okay, we are done. We could actually call here, I don't remember why I had return here. Yeah, I know why I have it. So we return. We decided that's it. We are done with the whole file. Now, here we have another one. Line, another condition doesn't really matter. Again, return. So now what happens? It doesn't matter return because this isn't a function. It leaves the with statement and also the function and goes on. But because everything is in a with statement, this immediately also closes the file. If I had it with an assignment, then I would have had to remember before calling return every time closing the file. Okay, so that's another reason why to use the with statement, is because otherwise I would need to remember. I am surely will forget it. Okay, knowing myself, I will at least one place forget closing the file. Okay, and this solves it because the with statement automatically closes. Okay, so maybe I should give a little bit of explanation here. So before we go on, so the most common way to read and deal with a file is what we saw earlier. Open the file, read line by line, and deal with the current line, whatever you need to do it. You do some processing on it and so on. Okay, this is like the most common thing that we do. A much less common thing is that we need the whole file in the memory at the same time. We can do this, and for example, in two major ways. One of them is the read lines function. So here I open the file again, and I called fh read lines, and what I get back is a list where each element of the list is a line from the original file. So if the original file had, let's say, 17 lines, then this list is going to have 17 elements. Okay, and then I can print out the number of lines. So this will print out the number of lines because the len of lines list is is the number of lines, and I can go over actually the lines if I want to. Okay. The main drawback of this is that you actually loaded the whole file into memory. So if the file is big, you run out of memory. Okay. Rarely you need this style of processing, and then you have to deal with the question of, can it be, is it possible that one of the files I'm going to deal with is huge? And if it is, then you will have to think about some totally different and way more complex processing. But as long as the file is relatively small, and I'm saying relatively because it all depends on the size of your of the memory of your computer, the free part of the memory. Okay, so because all kind of other things are already running in your program, in your computer. The other way to read in the whole content of the file is using the read method. So here I again open the file just as earlier, and then I call it fh.read. This will read in the whole file as a single string and put it in this variable. This is especially useful if you're looking for, let's say, a text that might start on one line and end on a different line. And then you're going to use a regular expression that we'll learn later to find that thing. Okay, but you dealing with it line by line is extremely difficult, because it starts from the beginning one line and ends on a different one, and then it's very difficult to find this if you're dealing line by line. So that's why it's sometimes important. Here too, the same issue. If it's too big, then you have a problem. Okay, and then you will have to think about all these other possibilities and whatnot. Okay. Some people call this, especially in Perl, they call this the slurp mode, because you whatever slurp in the whole file into memory. Okay, so what happens if a file doesn't exist? Just to give you an example. So here I have a file that actually doesn't exist on my disk, and when I try to open it, I get this exception. Okay, so it says no such file or directory and gives me the name. This can be coded with a try except block that we'll see soon. Next slide, I think. But you have to remember that can happen, that the file doesn't exist, you don't have rights or anything, then the open fails and raises an exception. So how to deal with this? And you actually had an exercise already, the solution that you used it, but now we can go quickly over this. We say try, and then inside the try, we write the code that can raise an exception, okay, whatever it can be. And then we have this except part. So we say except, and then we put in the type of exception that we want to catch. Okay, and then optionally, we can say, okay, save the actual exception object as the variable, let's say ERR. Okay, again, this is just a variable name. You can use anything. Many people use the letter the letter E, but I also used to use just the letter E here, but I really started to prefer using multi-letter words for everything, even for these things. So now in this except block, you can actually print out any free text, ERR itself, the type of ERR, what is the type, and so on. So it's whatever. So what happens here is that if there is any exception in this part, then instead of, without the try except, it will end the program and you will get this output. Because we have the try except, Python will check if the type of the exception is what is written here. And if it is there, then instead of stopping your program, it will execute this part of the code. Okay, we code the exception. If there is no exception here, then this part won't be executed at all. So if everything works fine in here, then this part won't run. Okay, and this one will run anyway. Okay, no matter if there was an exception or not. Now, here I write exact exception, and you in your example wrote, I think, I don't know, value error or something like this, right? So
Yeah.
Python exception hierarchy. So you see, Google understands even if I have typos. So this is the documentation of Python 3. At the bottom of exceptions, at the bottom of this page, you have a hierarchy of all the exceptions, all the built-in exceptions of Python. You see there is this exception, and this is a tree. So and if I say I catch anything which is an exception, this word, like I had in the example, so I said except exception, it will catch anything which is below it. So it would catch file exists error. It will catch, I don't know, timeout error. It would catch the value error that you had, anything. Okay, so it's like sweeping under the carpet sort of thing. You could be more specific if you wanted. Okay, so that's the idea here, that you can be really specific, that if I get this kind of error, then I deal with it. If I don't, then I don't know how to deal with it. But here in this case, I didn't want to deal with this. Actually, exception is not everything, because there are 3 other exceptions that are not below exception. For example, if the keyboard interrupt is when you press Ctrl+C. It's translated into an exception inside Python. So theoretically, you could catch it. And then if the user presses Ctrl+C, you could say, no, I won't exit, and go on running. Okay, so you can do this this program. It's a fun thing to mess with people's head.
So with this try and except block, could you do it in a way that you have more than one except?
Yeah, you could. Yeah, so this is part already of the advanced chapters, but yes, you could actually give it a list and say, okay, if this or this or this exception, then handle this. Or you could have several except statements. So if this type of exception, do this. If some other type of exception, do this. So
do you actually need to use the if condition there, or is it just writing except?
You just write a couple of these excepts under
right.
each other, right? Yeah.
Okay. Thank you.
It's a very powerful thing in knowing how to handle something that happened down below there. Okay, so I mean, here it's not that interesting in this example actually, because what we do here is we have a file, we try to open it. If we didn't, then we say we couldn't, and that's it, we are done. A way more interesting example is the next one. Here we get, so we say that from the sysargv from 1 to everything. So this is all the files, so you can run it like a name of this program, and then you give a lot of files on the command line. Okay, a list of files, and this will go over each file name on the command line, and then each file, it will open the file, and I don't know, do something here. What does it do? Go on line by line. It reads, assumes, like, apparently assumes that the line actually has a floating point number in it. Okay, reads in it, puts in the number, and then adds it to the total and counts how many of these we had. Not a very complex thing. Apparently it has not, those files are numbers. They have, here it is. So these are the files, okay? This is one file, this is another file, okay? And then you can run it like this. Okay, number, one of the files, yeah? And then the empty file, and then the number per line 2, which doesn't exist. Okay, and anyway, and then the whole thing is wrapped with try except. So what will happen is that if you run this program, at one point, I don't know what's here. Maybe I don't have the input correctly here. Anyway, if there is any problem here inside, if we can't open the file, or if the float fails, right? The float also raises exception, but we are catching any type of exceptions here. Okay, so if whatever exception happens here, it will be code here at the except part. We will print out there was some trouble in this file. We'll actually say the name of the file and the error type, the error itself. But then we go on to the next iteration. And that's the nice thing here, that we here at the top, we can decide, okay, we do something with a file, and later on maybe this will be in a function imported from a different file, maybe written by someone else. And you who using that function, you say, okay, I will call that function that does all kind of operations that might raise an exception. And I want to continue. Okay, I'm going to print out, so the user will see that there was some trouble with this and this and these files, but I would like to continue to process all the other files. And at this level, it's your decision what to do when there is some problem. And you could even say, okay, we had the. So I think these are, I didn't print out the type of the error, only the name. Maybe you should print out the type, but you could actually, based on the type, you could do some different things. So let's say if the file didn't exist, then you just continue. If there was a computational error, then you maybe stop, because you say, oh, there is a garbage in the files. Okay, it's up to you. Okay, but this is the really interesting part already. Okay, so that's more or less about reading a file. Now, writing a file, we open, I didn't have any of these examples. Ah, here it is. Sorry. So here you can see, you didn't complain. Oh, I was expecting you were complaining somewhere. So I didn't say R. I just said open file name. And reading is the default. I thought I already had it earlier. So anyway, you don't have to write open for reading, sorry, because reading is the default. Okay, that's the only thing I wanted to say here. Writing, you put a W here. And when you open the file now, you have to be careful, because once the open happened, if the file existed, now it's empty. It's gone. It immediately empties the file. So it rewrites the file.
All of it.
All of it. Okay? And then out.write, this is how you write something in the file. And of course, you can call write as many times as you would like. Okay? But this open file name, this already creates the file empty, or if it existed, then it empties it and creates and replaces it with a zero size file. So you have to be sure that that's what you want.
Right, so that's why you have the append as well.
Right. So I mean, append is actually a rarely used thing. So in almost every time when you have a file, it has some kind of a format. So if you would like to update it, you probably read in the file, add some to the content, change the content, and then write out the whole file again. Okay, so for example, if it's a CSV file, usually you would read in the whole thing, add a couple of lines or change a couple of things, and then write out the whole thing again. If it's an image, definitely you can't append to an image. Okay, you do changes. Okay, so append is usually used if you have a log file. So something like you do some processing and you would like to have some place where you write, okay, I did this, this happened, and so on. And this type of file is usually when you're appending. Okay, but in most files, well, let's say you have a text file with a report and I don't know what. Maybe there is a placeholder for the author. So you have a text says author. and the program needs to replace that text with your name, for example. So you read in the file, change that value, write back the file. And you don't, and it's two, you have to open the file twice, once for reading and then once for writing. Okay? And just this is a whole different concept from what you think as a regular user. Like you open the file and that's it, and then you save it. These are the, yeah, so this is like you say save. What actually happens in the editor, it takes the whole content from the editor and replaces the file on the disk. So this is what write does, okay? And append is actually, so if you open it with an append, then it leaves the file as it is, or if there was no file, it creates it. And then everything you write, the same thing, it will just be added to the file, which is, again, it's relatively rarely used. Okay, so I mentioned logging, so there is a specialized library for logging, so you wouldn't actually do this yourself, okay? You just have to configure it to append, but you would like to do it. So these low-level things are important, but you mostly deal with specialized files like this. If you have generic files, then you most likely going to have some library dealing with them. Binary mode, so now we get back to the binary mode. In the really, really rare case that you need to deal with a binary file, that's not a well-known file format, so you don't have a module for it already, then what you do is you open for reading in binary mode, RB. And then you don't read line by line, but you say filehandler.read, and you say how many bytes to read from the file. And then you have to deal with all the mess there. So it's much better if you don't have to deal with this. Okay.
Just one thing quickly with the previous one. What is pass at the end at the exception?
Okay. So good that you're pointing out. So this is the construct: try some code, accept some code. And Python doesn't allow you to have. So I didn't. Okay. The thing is, I didn't have anything to write here. I didn't know what to do. I just wanted to focus on this part. So, but you can't leave it empty because Python doesn't allow you to leave a block empty. So there is this special keyword pass that just say, oh, just don't do anything here. Just keep going, okay? So this is just a special word in Python that doesn't do anything. It's just there to fill out the empty space.
So in this case, if there were an exception, what would happen? Would it just go on?
Totally under the carpet. Like, okay, there was an exception. I caught it, and I don't even tell anyone about it. I just keep going.
We just go on. Yeah.
Yes. Okay.
That's funny.
Yeah, I mean, one of the main uses it, I think, is when you start writing your program and then you focus on one part, but the syntax requires you to fill the other part. So you just put pass because you don't want to concentrate on that part now.
Right.
And then you have to remember, hopefully you'll remember that that you have to do something there.
Yeah.
But yeah, so that's the main use, I think, of this pass. Okay, does the file exist? So you can, when you open the file, if it doesn't exist, you would get an exception. But you can actually check the file already before you even try to open whether it exists or not. So there is the OS module. So you say import OS, and then you can say OS pass exists and give it a pass to a file, and it will return true or false. And then you can also ask if it's a file. So on the disk, you might have files, directories, or folders, or whatever the name is, okay? And then you can actually have a couple of other things, at least in Linux, maybe also in Windows. which are not files, not directories, but all kind of other things that are needed for the operating system. But anyway, then two main things. You could ask if the path that you got, so the user gave you a path and you would like to know, is it a file or is it a directory? So is file will return if the thing exists and it's a file. And is dir will return true if it exists and it's a directory or folder. Okay, just an alternative name for it. Okay, in general, OS path has all kind of other of these capabilities. Let me. So there are lots of things. So this was the one that we used, exists, but I don't know. There are many of these tools. Is file, is dir, is link, is mount, join. That's another interesting. So lots of other things. Right, yeah, I just moved it here. So once in a while people ask me, how can I access line number 3 in a file? And files on or operating systems don't have that capability. The file is just a series of things. So you can't jump to some other place, some line, okay? The only thing that actually the computer knows is that to jump to character number 73, but it doesn't have the actual understanding of lines. That's your concept already, okay? Because where the new lines are. So that's not possible on the low level. What is possible is to go on, iterate over. So one of the ways, so the same way here that I had a list and I accessed element 1 in the list, I can't do that with files, but what I can do is either read in the file in memory in a list, and then I can already access line number 3, or I can iterate over like this. I have no idea what I am showing here in this example. So this won't work. That's the main point, okay? That you have the file handler and then you access something. This doesn't work, okay? It's not scriptable, okay? What you would probably do, maybe I should add this example here, is iterate over the elements and then you count yourself. That's what you can only do, okay? Or read the whole thing in as a list already, you can do this. Okay, any questions here?
No, I don't think so. I think it's quite clear for now. Okay,
so let's go over the exercises. The first one, and some of them, or maybe all of them, are quite similar to are extensions to previous exercises. Now we only have the data in files. So for example, here we have a file called numbers.txt with content like this, and I'm expecting you to print out how many times each digit appears. Okay, that's it. I mean, we already had this example without file. If you have a text file with lines and new lines in it, how can I read the whole line and removing all the new lines? The color selector. Yeah, we had the color selector. So now the extension is that you get a file called colors.txt. Okay, you can write it with a U because they're from England. Okay, and it has a list of color names in it, like each color on one separate line, and that's it. You use that file, you use the whole operation based on that file. So you don't have the list of colors in the file in your program anymore. Everything is outside. Okay. ROT13. Okay. ROT13 is one of the most the oldest encryptions. Okay. It's the idea is that you have 26 letters in the Latin ABC. So if you move, and if you think about them as a circle, you can move everything to the 13 characters to the right. So I don't remember. A will be K, I think. I don't remember what is number 14. Okay, so A is the first character. You move it 13 to the right, and that's, let's say K. I don't remember which one. Do I have it here? No. Ah, I can link it here, and I think, yeah, N. Okay, and B is O. So there you have this mapping. And the interesting part is that the N will become A. So they basically are swapped because it's 26 characters. Okay, so you have a text, you rotate it 13 characters, that's the rot, and then you have a new text. So let's say hello, it becomes this urib. And then you can send it to someone, and the person can do the same. Again, rotate, and the person can rotate to the same direction, because it doesn't matter the direction, because in both directions it's 13. So the same function can do the encryption and the decryption. Okay, so the idea is that you implement this rot13 function, and the whole thing is you get a file name and replace the file with the rot13 version of it. And you can check that it works, because if you run it again, you should get back the original file. Combining lists. So, yep, I have these two files, A and B, where I have some, whatever these are, fruits, no, vegetables, yeah, and some numbers, and here more vegetables and numbers, and combine them. Okay, but notice that avocado exists in both, but tomato only in one. And the result, I would like the tomatoes and all the avocados together. So you add the numbers together. I think you should be able to do this already, all this. Okay, with all the
We'll see, I suppose.
With all the tools we have learned. Okay, so these are the exercises, and if you don't have any more questions, then just enjoy the exercises.
Thank you.
And see you after them.
Right.
Okay, so bye for now. Enjoy.
See you.
See you.